Thank you, guys. I'm sorry, but you need to share one of the microphones because we only have two. Thank you so much for your presentations. I really appreciate your very formal and also very thorough content. Let's talk about the future and let's talk about the accuracy of predicting it. So you both mentioned mechanisms or systems or protocols where we are interested in looking at how things, prices or events, outcomes of events will evolve in the future and how we can credibly assess their outcome. JP, what you started with is a model of pricing options for gas, for infrastructure. How do you see the industry and where do you feel those predictions could be very influential in designing key new markets or new market mechanisms? What is the gap between today's development and real case applications in practice? And where do you think, what do you think is missing so that we can reliably build high-paced, high-accuracy protocols that would credibly leverage your research output?
Yeah, no, that's a really good question. So, I mean, let's start with utility. I think being able to having like derivatives on block space markets that can be massive for like inclusion list, for guaranteeing execution, for MEV. It can really hedge that, so it can make it more efficient. But it can become its own thing as well. I mean, like options exist as a way of hedging, but it's probably one of the most degenerate things that you can do on the internet if you go on Wall Street bets. So it can create its own thing on that end. Now, what's missing? So I think being able to price them accurately is important because you that price is a measure of the risk that you're willing to take. So that price needs to be accurate, otherwise you might be overestimating or underestimating your risk. But as I was mentioning in my talk, I think there's two specific parts that maybe we can explore a little bit deeper. The first one is, okay, how do we compute this on chain, right? Because these are not like simple computations. This will be expensive to do. You need to do Monte Carlo. Maybe you can do it distributively. Maybe you can do like some fancier type of Monte Carlo as a multi-level Monte Carlo or something like that. But it's still expensive. So like trying to come up with methodologies to reduce that cost, it's definitely important. And the second one, which is probably the most crucial, is creating the specifics of the assignment of the option. So if I'm a contract holder, right? If I own an option that you sold to me, and you are someone a block builder, then I need to make sure that my transaction will be included when I want it to be included. And that part is definitely not trivial. But I think if we only solve those two very difficult problems, it can lead to a huge market.
And can you talk me through how the situation is today? So do those option markets even exist, or is this just a theoretical concept that you're exploring? And
no, so I know that there have been protocols that have attempted to do this. I don't remember exactly why they're not alive anymore, or if they're alive anymore. But it's definitely not new. But yeah, I think there's multiple factors to it. So the first one is that pricing is not trivial, assigning is not trivial, and yeah, I wouldn't know too well how they are actively handling this. If it's like a private set of executions or stuff like that, I don't know. I think it might be one of those things that might be easier to fix at the protocol level or at the chain level, just because it can become a terrible coordination problem. Or you have an option that is not that you exercise at a specific block, but you exercise at a specific window. Mm-hmm. So like, I don't know, if you propose 30% of blocks, I know that with high probability, in I don't know, a space of 300 blocks, you would have proposed at least around 100 of them, right? So maybe if you take this into account, like this window into account, it might become a little bit easier to implement. But then there's the trade-off that the pricing of an instrument like that becomes a little bit trickier. But
Right. So the concepts that you explore in theory, there might need some further additional steps to be iterated over so that you can actually make the mechanism realizable in practice, right?
exactly.
Okay, so let's talk a little bit more about that. But before we do that, maybe please hand over the microphone to William. I would like to frankly kind of have a discussion with you about the process of developing, conceptualizing, and exploring the mechanisms that you propose. Given that the mechanisms that you propose are anchored in a particular protocol or a particular use case that you want to develop them for, but you draw your knowledge from a rich body of literature, specifically peer prediction or information aggregation, and you alluded to this in your talk at the end, in the conclusion, but also at the beginning, that there are many different forms of sources that you could use and different inspirations that you could use in order to start your design process or start your mechanism exploration journey, so to say, right? So if you could help us a little bit maybe, and also the audience, to understand, like, how is it that when you start with a particular target design of a mechanism, how do you reach out or reach back to literature and try to anchor the specific points that you're interested in into an actual mechanism design? And based off that, we can...
Sure, thanks. Yeah, so for drawing from peer prediction, this is something that's been on our radar for years. You know, I've been working on the Kleros protocol since 2018, and like, you know, very early on, like, people giving us feedback, like academics and such, were like, oh, are you aware of all these peer prediction mechanisms? And I look at that, you know, like my reaction was, well, it doesn't seem very collusion resistant. You know, it's interesting, but like it sort of like filed it in the back of my mind as like I don't see immediately how we can use this. And then for this specific mechanism that I'm working on now, relating to try to like reduce risk for our, you know, participants in categories of disputes where that you have really unbalanced like rates at which participants win. Like my inspiration came from the people, like our users complaining on Telegram that the deposits are really high, and you know I'm not comfortable with this level of risk. So you know, like at that point, it's like thinking, okay, like what kinds of like I have a new problem that I'm trying to solve that, you know, I wasn't necessarily on my radar before. How can we adopt the mechanism? What can we do? And at that point, somehow, you know, it triggered something in the back of my mind. It's like, oh, you know, like maybe you can draw something from like this peer prediction stuff that, you know, is compatible with our collusion resistance assumptions. So, you know, that's sort of the, you know, the origin of this mechanism. Generally, you know, listening to your community and like trying to like get a sense of how people are actually using the protocol, whilst at the same time, you know, thinking of all the possible attacks and you know, evolving from there.
That's interesting. Okay, one of the main differences between the solutions that you propose or the topics that you talk about, at least from the point where I stand, is that, William, you are talking about very specific, discrete, and influential events that people, you know, have predictions about or votings on or want to resolve, right? And in your case, JP, we are more on a minuscule scale where we are talking about pricing gas options, where those changes or like those events happen more frequently, and therefore you have much more, let's say, flexibility, or it's not so impactful what happens in a particular time step, right? So when we talk about risk in this context, right, for you, obviously the measure that you're looking at is volatility, right, which you're trying to assess. What about you, William? I mean, like, if you say people are unsatisfied with the risk of participating in something like that.
Yep.
I imagine that if you have kind of like a legal resolution and you need jurors to vote on something, this is a lifetime event potentially, right? So you don't really have the time or the chance to say, okay, screw the first outcome, let's replay the game and play another time, right? So how can you manage risk in your situation? This is the question.
Yeah. So, like so there are two perspectives here. There are perspectives to the parties to the dispute. There are also the perspectives of the jurors. I mean, the jurors, in theory, they should be relatively sophisticated actors. You know, they're doing this as like a repeat game. They're members of a community that like they know they're getting. It's like gig work to be a dispute resolver. Like presumably they're going to do more than one dispute, and like they realize there are these risks you might be wrong in any given dispute. But like particularly when the deposits are really high, even if it's like the game is repeated, like one really big loss they might not be able to recover from. Like normally the like this is a lifetime event. I'm having like my dispute is being resolved would probably be from the party's perspective, the people who have are the opposing parties in a dispute. However, you want to provide acceptable risks for everyone involved. But yeah, you can't like iterate a whole lot when the protocol is live. You can just try to be better, in the future. Like in terms of having like the continuous versus the discrete, like I feel that you probably have like much more data to work with than we necessarily do. We have thousands of disputes historically, and that gives us a certain amount of data to work with. But like particularly stuff like risk aversion is not something that like is really visible in the data. Like you don't know what like the only response that we see in the data to like jurors being risk averse is that they stopped being jurors and they left. But they could also like stop being jurors for all kinds of other reasons. So the data is like really noisy, and I feel like a lot more of validation in this kind of setting is to have like surveys and maybe lab experiments. We haven't done those yet for this mechanism. We've done some lab experiments for other mechanisms we've considered. Our PhD student we're working with, Yan, who's sitting in the audience, has organized a bunch of lab experiments for to test like how do people respond to different mechanisms. And I think that might be particularly relevant here, given that like risk aversion is a personal thing.
Okay, but this ties quite a bit into the perception of the mechanism, right, by the participating parties. It connects with behavioral economics, for example, interpretations of specifications or mechanism definitions. How about taking one idea that JP proposed today and implementing an option market for dispute resolution outcomes? Is this something that like you think could work? I mean, by doing that, you could externalize the volatility to some extent. You can try to cap it by externalizing the risk of an outcome to parties who are willing to take the risk.
Yeah, so in terms of having an option market for dispute for like the dispute outcomes, like like some independent market where you're like you can hedge against like Alice winning or John winning. I feel for the parties to disputes that could potentially be valuable, and that I mean on some form that would be kind of like a version of settlement between the parties, assuming those are the ones participating in the market, and that they like agree to. Maybe there's still some underlying dispute going on, but they agree to, like even if like John wins, Alice gets paid out something because she bought the like John option. Like the jurors' incentives, I consider this like a challenge in that it like gets back to these questions of lazy strategies, and the jurors by participating in an option market can dilute their incentives and be like, well, like. Yeah, there's this huge deposit that I might get slashed with like, hard cases or whatever that's discouraging from being a lazy participant. But what if I just like, in addition to using whatever in-game incentives I have, I'm also like speculating on the options market. It becomes harder to disincentivize the lazy strategies. In like an extreme advantage situation, you can imagine that like the right bundle of juror incentives plus options always gets you out to a constant payout of whatever the average fees are, whether you're doing any effort or not. And how do you disincentivize this? We've considered as a module in version 2 of Kleros, which is in the process of being released. This module isn't live yet. Having like a juror misbehavior court where jurors can be slashed basically for certain kinds of behavior. If people realize the jurors are doing something, that would create secondary disputes. People can challenge them, and then the other jurors can vote on whether or not they broke the juror code. And this is something that like I would consider like, you know, anti-juror behavior, where if you're a juror, you should not be speculating on an options market on the case.
Okay, so is the argument that you're making here is that in some cases, specifically for, you know, dispute resolution, for example, it's very good to have high stake games so that you get the incentives right and people behave honestly.
Yeah.
And for other cases where, for example, we talk about infrastructure, you would want to get the risk out of the way and have predictability of future pricing so that infrastructure that is built on top of this can reliably understand the costs and risk. So that's very interesting. Okay, cool. Perfect. So, JP, back to you. William, like one of the biggest points that he was making is working under adversarial conditions. What about your model? I mean, have you investigated this? Have you been looking into this? Have you been looking into pricing scenarios where people might be adversarial in this case? Like, how would this just, you know, change the volatility, or is there something more to it?
That's an excellent question, and it really goes like to the depth of the theory, because when you're pricing options, at least when you're pricing options with under the equivalent under the martingale methodology, one of the underlying assumptions is that you have an efficient market, and an efficient market sort of precludes the fact that there are adversaries or that there are arbitrage opportunities and things of that sort. So you're kind of working on a nice, let's say, environment. So yeah, I mean, I think you could map it back to an adversarial scenario, but you would need to sort of understand what is this change of measure between like the risk-free and the adversarial one, and it's not always easy. It's not always easy to do. So, I mean, I guess what I'm trying to say is, I guess pen and paper you could do it, but ultimately you will need to come up with either like a model for this adversarial component or something like that, and I think once you start doing that, the model might start losing some validity, because you're putting more and more assumptions to it.
Okay, so what would be even the adversarial behaviors in your environment? Is this like someone who is intentionally trying to spike the gas price?
Yeah, so someone who just, I don't know, sends an empty block, or that, like if in the hypothetical scenario where there's like a controlling entity for the blocks, right? That entity decides that that they want the price to go up because whatever reason, as opposed to, you know, let demand forces play with it. It becomes super messy. I don't know if it can be done. Yeah, exactly.
But isn't grieving something that you could apply to this scenario? I mean, like just having someone who is trying to just.
Yeah, interestingly, like there have been like a variety of people who've written academic papers on griefing since Vitalik sort of introduced this version of this concept in the blog post. And one of the papers, in fact, maybe Vitalik wrote this, is on discouragement attacks on proof of work systems, where the idea was that like you mine in this is, you know, related, maybe not exactly the same thing. If you're like a proof of work miner, you mine beyond what it makes sense for you to mine. You like mine at a loss, so that the difficulty adjusts and goes up, and all the other miners are also being forced to mine at a loss, and they eventually just leave the system. And I could certainly imagine something like that happening with the gas market, where you're trying to like push out competitors. Maybe you have a censorship attack. Part of the like issue with griefing is that you know, it's defined in terms of the in-game incentives people have, where it's like, okay, like they're doing me harm and they're taking a loss, but you never really know what people's external incentives are. Like maybe they're trying to sabotage you because you're some kind of competitor. Maybe they're doing a gas attack because there's like their competitor wants to get a transaction in, and they're strategically trying to censor them by raising the gas. So yeah, certainly.
But this is also a threat to the security of the system, right? Because if you crowd out competitors or a multitude of other validators, you can take over control.
Yeah, I mean, like ideally, for the discouragement attack where you like artificially raise the difficulty of the network, or like the gas is too high or something, and people have left because they're frustrated and they're losing money for a long period of time. Once you're in a monopolistic position and you like go back to normal equilibrium where you're not at a loss anymore, the people will come back. But in reality, like there's friction, and your competitors might not come back.
Okay, so you're saying that attack is only as long effective as people are actually working at loss, and afterwards they might.
Yeah, I mean it depends on the attack, but the specific sort of discouragement attack on proof of networks is like that.
Perfect. Let's talk about implementation and practical translation of those concepts into real world. Okay, so what you have laid out is like an academic paper, a model that is helping us to understand very deeply how those mechanisms work and how gas options could be priced. Is this something that needs additional attention when we talk about blockchain systems? Or is this something where we say, from this theoretical model, it's enough for us to understand how we can build the EAP 1599 mechanism, and it's good enough for us to proceed? Or do we have to make any adaptations to the theory or any adaptations to the understanding when we really want to build blockchain protocols out of it?
No, so I think the theory doesn't need to be adjusted, but it could definitely be refined. As in, again, it's a pricing methodology, right? So you can come up with either a more accurate pricing or a more a faster way of obtaining that number, right? But the theory is there. I think that the complicated part is moving from, okay, I have this oracle that gives me a price of how much this thing should be, moving from that to the actual set of rules that you would implement on a blockchain or on a protocol to make this happen. And it's tricky in the sense that, I mean, to me the easiest way is to, if you sort of do it at the protocol level, like if it's a default, you sort of pay, like the one that sells you the option is the blockchain, and then the one who receives the payment at the end is the block builder. But that of course that's not an easy change to make, just because it involves a lot of social coordination, plus lots of engineering work and things of this sort. But or maybe at the I'm trying to think whether you can do it at the app level. Maybe at the app chain level you can do it a little bit more easily. But I would need to give that more thought. But yeah. To answer your original question, I think the theory is there. It's sufficiently broad to cover, the pricing part, but then there's the implementation part, which is
right.
trickier.
So we would expect a proper insurance market to emerge on top of block production.
Yeah, you could have that. Yeah, and it would be, yeah, that would be a canonical use case of this, like gas insurance. So I don't know, like few years ago when USDC was depegging, I had a few USDC, not that much, but I tried to change it, and I don't know, I spent like $500 on transaction fees. If that existed, it would have been, the usual amount.
Was this the reason for you to start thinking about?
Okay. That's my origin story.
Okay, and now when you have it, like, what is the plan ahead? So, like, are you the one to trigger this insurance market somehow?
Probably not. Or maybe, I don't know.
Okay.
But no, I mean, I think I would like to dive deeper into the mechanistic part of how can this be implemented. Maybe not like from the entrepreneurial part, but from the mechanistic part of,
right,
hey, this is what you need to do at the protocol level so that this can be realized. And if there's enough buy-in, then yeah, we can take it from there.
That's actually a very cool extension to like consensus mechanisms
Yeah.
by integrating an option market on top of it. Very nice, yeah. William, your research is much closer to the way how your protocol operates, right? So like the distance from whiteboard to implementation, it's probably going through multiple iteration cycles in-house, but how do you see, like how much cuts do you need to make to the stylized results that you have on paper when you go towards an implementation at Kleros?
Yeah, I mean, like, this mechanism can be implemented, like, already. There's a bit of a question of, like, you maybe want to do more experiments. You know, as I mentioned sort of earlier, maybe there might be behavioral experiments in the future. Maybe there's some slightly different version of this mechanism, which is more appropriate. Like, more reflection can be done, but, like this mechanism is not far off from the kinds of mechanisms that we have and can deploy, and it could be deployed as is. So the current version of Kleros, which is being developed, the V2 that we've been working on, is sort of modular in its design, so that you can deploy different incentive and voting rules that are used for different kinds of cases, and we can identify that, okay, in these kinds of cases you have like really unbalanced rates in which the people win. So this is like an appropriate use case for the peer prediction dispute kit, and like the devs have to code that dispute kit, but like there's not a very long path from whiteboard to eventually being able to be deployed.
And when you say this mechanism can be implemented, is this, I mean, like the criticism, is it that it is difficult to do so, or is it that you say maybe like it's a mechanism that might not find strong adoption because it's just too niche or too complicated, or like where is the bottleneck really? Is it in the usage, or is it more in the technical challenges of implementation?
Yeah, I don't think for this dispute kit there's like usage will be the problem. We've identified like this has been like an issue in a variety of the categories of cases we've had up to this point. So I think that this like set of incentives will have a home. So maybe some of the other dispute kits that I've thought about are maybe a bit more niche. We'll see if they see the light of day. Mostly it's just like the bottleneck is just the devs' time, and we have a lot of exciting projects that people are working on deploying. There's an order of priority, like the dispute kits which are being deployed for V2 now are like higher priorities, but like I don't feel this one is too far down the list.
Okay, let's talk about data. Sorry.
No, if I may interrupt. No, that I was just going to tell to Will that I think it has a nice application on validation markets. So like I'm doing something, someone is checking me to do it, or a committee is checking that I did the job, right? But for the committee to check that I did the job, it costs them some effort, some compute or whatever. So if they're lazy, they can always be lazy, and they just say that I did the job based on my reputation or my score or whatever, or my history, but that becomes poor UX like very quickly. So if you have like these mechanisms to keep them in check and keep let's say the prover in check, I think that's very valuable, and it has applications across many different things.
Perfect. Let's talk about data availability and market depth. You mentioned that it's quite easy for you to observe, obviously, like what's happening on the gas markets, and you have all the data at your disposal, which probably makes the models or the predictions that you make more accurate, or like more closer to future outcomes. How does it work with, like how accurate are your assessments when you are lacking this data availability, right? And this might be even more prominent in your case, where you have probably less participation, more specific events, and so on. So how can we make the prediction models more accurate, given that we have limitations with respect to data availability?
So in my case, you definitely need data. Maybe you don't need the most recent data, but you need two types of data. The first one is you need the current base fee and the gas usage, you cannot do without that. That's just one data point. That's not too bad, and it's at the header of the block. And if you assume, which is one of the assumptions that I'm working on, that the distribution, this joint distribution of relative usage and base fee, that it doesn't change over time, the distribution, then I mean, basically, like if usage patterns are the same today as they were 1 year ago, like there was no big EIP that collapsed gas cost or any major upgrades, then it's fine, right? Because you are simulating from this snapshot of what this joint distribution looks like, but because it's static, it's the same now as it was before. So yeah, you don't need to keep adding to it. At some point, you're going to have too much data, and it becomes a computational problem. So yeah, but there's that specific caveat. If this distribution were to change, or if protocol upgrade were to happen, then this assumption is not valid anymore, and you need to collect again sufficient data so that you can construct this joint distribution.
How do you deal with limited data?
Yeah, I mean, a variety of ways. You can try to like use mechanisms and prove theorems that are, that are strong even in the absence of like lots of assumptions about the data. Like the theorem that I had at the end of my talk said that the average deposits went down or something, that were like the average slashing went down as long as, and you're better as long as you have risk-averse participants. How risk-averse? It doesn't matter. As long as they're sort of like more, lambda bigger than 1, they're helped by this mechanism. You don't necessarily know if they're helped enough for it to be worthwhile for them to participate in the protocol, but it's like you haven't done harm, or you've made things no worse. So like you can try to tune parameters when you need to tune parameters in ways that are conservative. However, that can lead to in like version 1, when we're trying to deal with lazy strategies, and our approach to doing that is to have really high deposits. If you are conservative and you're like, okay, I don't have enough data, I'm going to err on the side of like even higher deposits because I really want to prevent the lazy strategies. I mean, that can make the user experience even worse. Like there can be, the lack of data can certainly be a problem. There's only so much data that you can get on chain from these very discrete events. Surveys and like lab studies can help. It's a toolbox of different approaches.
You mentioned in your presentation also that one way to think about those things is to be very conservative with parameter tuning, right?
Yep.
So is it a good strategy to say, like, as long as you don't have enough information, you are more conservative, even more conservative, you are more punishing to people who misbehave or who, and then you kind of like narrow down the band for parameters so that you kind of like let the system flow when you learn about like true behaviors or true.
Yeah, I mean, there are trade-offs here, and it sort of depends on where you land on the trade-offs. Like the parameter tuning that I described, trying to discourage lazy strategies is having the problem that you're raising deposits on the users, like ultimately is a trade-off between the parties to the disputes, good experience, and the like jurors' good experience as like two sides of the dispute resolution market, the like buyers of dispute resolution and the sellers of dispute resolution. The jurors are repeat actors, where, like if they're having a bad experience on like one case, hopefully it'll average out, again with large deposits, maybe it doesn't average out enough for them. The parties, they only have one dispute. If they have a bad experience, it's might hurt the like overall credibility of the protocol because they're more likely to like not have positive experiences that average out. They'll write angry criticisms, and ultimately, like particularly if you just fall into an equilibrium where it's just like everyone is using a lazy strategy, that's really bad. Maybe on something like this, we've been like really conservative, and the parameters we've been proposing and the governance has been voting on, because you really don't want people to fall into lazy strategies. On some other situation, maybe you can be less conservative, or you'd be on a different spot on a trade-off anyway.
how far away do you think are we or are you guys from, reaching the same accuracy as Polymarket, for example, in the case where they say they have the outcomes of presidential elections even ahead of the polls, right? Like even of the outcome polls. Like if you want to find up-to-date, accurate, like the quickest and fastest information on the internet, you are very keen to check with Polymarket to see like how did the event end? Like what is happening, right? Do you think that Kleros can achieve this level of credibility, accuracy, and kind of like position itself as the dispute resolution oracle?
Yeah, I'd say that there's somewhat different goals here. In that, for something like a presidential election market on Polymarket, they have tons of people who are have a pre-existing interest in that like want for whatever reason to participate in this market. Yeah, 538. Yeah, and there are a lot of people who have like an independent interest in this question that are like, maybe people are like almost to the point of neurosis where it's like you're like anxiety in advance of an important election. There's no lack of interest in those questions or some of like at least the high profile questions. Kleros was really designed for having questions that disputes that maybe are like require a lot of subjective effort. They take time, of the jurors to resolve, and that like you need to compensate them because like they would not necessarily have been interested in solving this dispute task. Like nobody cares about the dispute between Alice and John except for Alice and John, and you need the like gig work kind of aspects to like encourage people to come and like solve their task in a way that like Polymarket, they already have people who are interested in this task, so they can have a huge market where like thousands or more people are speculating. Where Kleros is really designed for like, okay, I have like these 3 random jurors, they were drawn. Their like task is to solve this question. Maybe there's an appeal to 7 jurors, and slide and up the chain of higher appeals. But ultimately, you want to be efficient in people's time because like it's a task for the jurors. It's like a work thing. The cost of dispute resolution is something you need to be cognizant of.
How is it actually at the inception? So I mean, did you have a cold start with respect to qualified jurors, or like did you have difficulties to find appropriate jurors or people to guide those resolutions, or has this improved over time, or like is it something that you have already baked into the protocol from the start? Like what was the bootstrapping?
Yeah, so who the jurors are is something that we've obviously thought a lot about. In version 1, we rely entirely on cryptoeconomic mechanisms to try to like have jurors self-sort themselves into like being qualified for cases. This whole idea that if you are bad at your job, bad at your task, and you're like losing money as a juror, you'll eventually ideally leave because it's unprofitable for you. Should like lead people to self-select. There's like a hierarchy of different types of cases. People stake to be selected in cases that are like of different categories, with the idea that people should stake to be in categories that they're good at. In version 2, we've explored a lot about how you can have more formal qualifications, how people can have like certain like SBTs that are say that I have some, I have like some, like I have a certification from the Token Engineering Academy, or I got like some, like specific like, some online school or whatever, I've like, like was that ECC, that like, state to some aspect of my experience, maybe that I have some SPT saying I'm an expert in whatever, that like I have some relevant case for, I'm an expert in, I'm an expert in like JavaScript development or whatever, and then you can require that to be drawn in certain cases, and like ultimately, like how many jurors we have in different kinds of cases, like a lot of the cases we've had so far have been kind of like blockchain-y native kinds of things, and the qualifications people need have been sort of sophistication and like ease of use with crypto, which ultimately if you're using a crypto platform you probably already have anyway. As you branch out to like more real world disputes, maybe the like SPTs and the formal qualifications are going to be more important.
And what is more relevant? Is it the collusion resistance of the mechanism, for example, like like how the mechanism works, or is it more the community that you have of people participating in the system, or is there kind of like equally weight between?
Like everything's important. Like you need the mechanism to be resistant to all kinds of attacks, including inclusion attacks, because if you fall into a bad equilibrium, you're not going to be credible as a dispute resolution provider. Does that sort of get to your question, or like?
Yeah, I mean, I think that by defining the mechanism in a way, you will secure some properties, right, and that you will make sure that regardless who votes, this specific outcome will have those properties as well.
Yeah.
But depending on the quality of the votes, it will probably be kind of crucial on whom you let to vote on particular things, right?
Mm-hmm. Yeah, certainly. Like one aspect on like the trade-off between collusion resistance and community, we depend heavily on our appeal system, so this might be a bit tangential to the question, but individual jurors in our panel, in a given panel, might go to our Telegram group where, for in many cases, as I was saying, that there's not a lot of independent interest. People might not care about like an individual case, but sometimes people are arguing about cases on Telegram. Just people are interested, even if they're not a juror. And like, how do you like draw the line between what is collusion? If like people are talking about the jurors are talking about the case on Telegram, like that kind of breaks away from this notion of a Schelling Point where they're like coordinating in the absence of communication. Like our way of thinking about that is that because you have an appeal and like you can go to like larger and larger panels of jurors who may not have been selected yet. They may not be following this. They may not even be staked, as jurors at the moment. You can have like a balance between like deliberation, where people are talking, jurors among each other on Telegram, other community members, and while still having like, defenses against unhealthy collusion.
Perfect. We have 3 minutes left. Closing remarks or questions from the audience?
Also that, right? No need for applause. So I work at Kleros, and I have worked with William for like 7 years now. We have discussed this many, many times. One thing is worth mentioning that it didn't come up in the talk is that some of the ideas for the modeling of the mechanism come from history, like the ancient Greek courts, private system of dispute resolution in England, 18th century, the Iceland system. One thing, and then the other is that lots of things, and this is from a commentary to which you can react. We have lots of ideas of what we can put into the court system to make it more efficient, to be cooler, like prediction markets, agents doing prediction markets about what is going to be the outcome of a case. But then when you go like to the customers, to the parties that will be subject to the decisions of this system, like traditional governments, insurance companies like MetLife that use it for resolving disputes between users and the company, fintech users, they could see those type of mechanisms like too weird and too far away from what they expect from like a dispute resolution system, right? So there is a lot of expectation of how this should work, even if it comes at the cost of sacrificing some of these cool ideas that we had over time. I know maybe you want to react to this.
Yeah, so just to like give context for your comments on like, Iceland and such, like there are these historical examples of financialized dispute resolution. So one of the things people complain about with Kleros, like potential users and integrators, is it's like weird that like the jurors, like they have financial interests and they're getting micro payments that depend on whether they're like right or not. There's a history of financialized justice where like in 17th century England and Saga era Iceland and other places, like prosecutors weren't public and like individuals would do this job in exchange for bounties. So like, it's maybe not like the most natural like dispute resolution platform when you have access to modern courts and modern jurisdictions. But when you're trying to come up with something that like works on the blockchain, is transnational, is like good and affordable for micro disputes between people across borders, it's not so weird that you have financial mechanisms. Like for people reacting negatively to like the weirdest ideas we've had, I mean, ultimately, I feel that like version 1 was very weird from people's perspectives, and as we deploy more modules, like we're trying to like come up with things that are crypto economically resistant and like sound while being more normal. Like gradually, the court is becoming closer to like a Web 2 like experience. I don't know, you might have context on like history of your.
But is it important for the participants to understand how it works under the hood? I mean, like all the mathematics that you've shown today, I mean, they're very impressive. Like, is it kind of good enough to say we have it thought through and we have the proof that it works, but you don't need to understand it, you just need to rely on kind of like the reputation of the system that we have, that this is a good protocol? Probably yes, right?
Yeah, I mean, I guess it depends on the person who's deciding whether or not they want to use this protocol. For some people, yes. Other people, like some people will be more convinced by like a mathematical proof. Other people will be convinced by a track record, of like success in previous cases. Depends.
Right. Cool. Any other questions from the audience?
Anybody else?
If not, then final remarks, closing statement.
I don't know. Like this is a good conversation. Like ultimately, like these ideas that I presented in my talk are fairly preliminary. Like eventually they may be further developed before they see light of day as a Kleros dispute kit. But I'd be interested to see if like the evolution of peer prediction ideas in this space. Like it's a really cool, rich field that is being underutilized because it doesn't fit so well with our attack models. But like maybe if you squint and look right, you can come up with something that like can be adapted, or like you turn it around and use it a different way that can add value.
Cool, JP.
Yeah, no, I mean not too many finalizing remarks on my end. Just thanking you and Angela for having us. Super interesting stuff.
Thank you very much, William, JP. Thank you.
I think we all agree. Thanks so much.